Hi, I am Shah. Welcome to Shah TechTuber. Today we will learn about AI tool Tensorflow and try to know about the process of TensorFlow. Tensorflow, a popular AI software tool, along with definitions and usage details. Definition of TensorFlow. TensorFlow is an open-source machine learning framework developed by the Google Brain team. It's designed to facilitate the creation and training of machine learning models, particularly deep neural networks. TensorFlow provides a comprehensive ecosystem for various machine learning tasks, from research to production. Key features. TensorFlow offers both high-level and low-level APIs, making it suitable for users with varying levels of expertise. It supports a wide range of platforms, including CPUs, GPUs, and TPUs, tensor processing units. TensorFlow has a strong focus on scalability, making it ideal for large-scale machine learning projects. It supports automatic differentiation, simplifying gradient computation for optimization algorithms. TensorFlow has an extensive library of pre-built neural network layers and models. It offers tools for distributed computing and model deployment. TensorFlow supports various data formats, including NumPy arrays and TensorFlow-specific formats like TF records. Usage in machine learning. TensorFlow is widely used for tasks such as image classification, natural language processing, and reinforcement learning. It's a popular choice for deep learning research and development. TensorFlow's Keras API simplifies the creation of neural networks, making it accessible to beginners. Transfer learning is made easy with TensorFlow, using pre-trained models like Inception and ResNet. It supports both supervised and unsupervised learning algorithms. TensorFlow can handle structured and unstructured data, including text, images, and audio. Development and deployment. TensorFlow offers tools like TensorBoard for visualization and monitoring during model training. It provides mechanisms for saving and loading models, allowing easy model deployment. TensorFlow Serving facilitates the deployment of machine learning models in production environments. TensorFlow Lite is a lightweight version for deploying models on mobile and embedded devices. TensorFlow.js allows running models in web browsers. Community and ecosystem. TensorFlow has a large and active user community, with extensive documentation and online resources. It's supported by a range of third-party libraries and tools for specific tasks. TensorFlow Hub offers a repository of pre-trained models and modules. TensorFlow Extended, TFX, is used for production pipeline orchestration. TensorFlow Model Garden provides state-of-the-art model implementations. Frameworks and integrations. TensorFlow can be integrated with other popular ML libraries like scikit-learn. It's often used in conjunction with data preprocessing libraries like Pandas and scikit-learn. TensorFlow can run on popular cloud platforms like Google Cloud AI and AWS SageMaker. It can be used with deep learning accelerators like NVIDIA GPUs. Optimization and performance. TensorFlow includes various optimization algorithms for training deep neural networks. It supports distributed training, allowing models to be trained across multiple GPUs and machines. TensorFlow's Graph Optimization Toolkit, Grappler, optimizes model graphs for efficient execution. It can utilize hardware accelerators like TPUs for enhanced performance. Research and innovation. TensorFlow has played a pivotal role in advancing the field of deep learning. It's used in research to develop cutting-edge models and techniques. TensorFlow Research Cloud provides free access to TPUs for researchers. Industry adoption. Major companies like Google, Uber, and Airbnb use TensorFlow for various AI applications. It's employed in healthcare for medical image analysis and drug discovery. TensorFlow is used in autonomous vehicles for perception and decision-making. It's applied in finance for fraud detection and risk assessment. Education and training. TensorFlow is a popular choice for teaching machine learning and deep learning in academic courses. There are numerous online courses and tutorials dedicated to TensorFlow. TensorFlow's Playground allows users to experiment with neural networks in a web-based interface. Support for multiple languages. TensorFlow is primarily developed in Python but provides APIs for other languages like C++, Java, and Go. This multi-language support allows integration into a variety of software systems. Version history. TensorFlow 1.x was the initial release, while TensorFlow 2.x introduced many usability improvements. TensorFlow 2.x emphasized ease of use, eager execution, and better integration with Keras. TensorFlow 2.x deprecated some features of TensorFlow 1.x to streamline the framework. Open source and licensing. TensorFlow is released under the Apache License 2.0, making it free and open source. These bullet points provide an extensive overview of TensorFlow, its features, and its applications in the field of artificial intelligence and machine learning. Here's a step-by-step guide on how to install TensorFlow on your computer. TensorFlow can be installed on different platforms, including Windows, macOS, and Linux. I'll provide instructions for installing TensorFlow using Python's pip package manager, which is the most common method. Prerequisites. Python. Make sure you have Python installed on your computer. TensorFlow works with Python versions 3.6 and above. You can check your Python version by running Python version or Python 3 version in your command prompt or terminal. Step 1. Create a virtual environment, optional but recommended. It's a good practice to create a virtual environment to manage your Python packages. This keeps your TensorFlow installations separate from your system-wide Python packages. For creating a virtual environment, open your command prompt or terminal and run Python mvenv TensorFlow_env. Replace TensorFlow_env with the name you want for your virtual environment. Step 2. Activate the virtual environment. Skip if not using a virtual environment. On Windows, \TensorFlow_env \scripts \activate. On Mac OS and Linux, source TensorFlow_env /bin/activate. Your command prompt or terminal prompt should now change to indicate that you are in the virtual environment. Step 3. Install TensorFlow. With your virtual environment activated, or without it, if you skip the virtual environment step, you can now install TensorFlow using pip. To install the CPU-only version of TensorFlow, which is suitable for most purposes, pip install TensorFlow. If you have a compatible NVIDIA GPU and want to install TensorFlow with GPU support for faster training, you can use the command pip install TensorFlow GPU. Step 4. Verify the installation. After installation, you can verify that TensorFlow is installed correctly by running a Python script or entering a Python interactive session. Command is import TensorFlow as TF. Print TensorFlow version TF__version__. You should see the TensorFlow version printed without any errors. Step 5. Deactivate the virtual environment if used. When you're done working with TensorFlow, you can deactivate the virtual environment by running command is deactivate. This step is only necessary if you used a virtual environment. That's it. You've successfully installed TensorFlow on your computer. You can now start using TensorFlow to develop machine learning models and perform various AI tasks. Here are some basic TensorFlow commands that you can use to get started with TensorFlow. 1. Import TensorFlow. Command is import TensorFlow as TF. This command imports TensorFlow and allows you to use its functions and classes in your Python code. 2. Create tensors. Command is #create a constant tensor. Tensor_a equals tf.constant, 1, 2, 3, 4, 5. #create a variable tensor. Tensor_b equals tf variable, 5, 4, 3, 2, 1. You can create tensors using tf.constant for constants or tf variable for variables. 3. Session, for TensorFlow 1.x, not required in TensorFlow 2.x. Command is in TensorFlow 1.x, you need to create a session to run operations with tf session as ses. Result equals ses.run, sum_tensor. In TensorFlow 2.x, eager execution is enabled by default, so you don't need to create a session for simple operations. For basic operations, command is #addition. Sum_tensor equals tf.add, tensor_a, tensor_b. #subtraction. Diff_tensor equals tf.subtract, tensor_a, tensor_b. #matrix multiplication. Product_tensor equals tf.matmul, matrix_a, matrix_b. You can perform basic arithmetic and matrix operations on tensors. 5. Hit a placeholder for TensorFlow 1.x, not required in TensorFlow 2.x. Command is #. In TensorFlow 1.x, you can use placeholders for data input. X equals tf.placeholder, tf.float32, shape sadface none, 2. In TensorFlow 2.x, you can use Python variables directly for data input. 6. Define a simple neural network with keras, tf2.x. From TensorFlow import keras. Command is model equals keras sequential. Keras.layers dense 128 activation equals relu input_shape sadface 784. Keras.layers dropout 0.2. Keras.layers dense 10 activation equals softmax. You can define neural network models using the Keras API, which is integrated into TensorFlow 2.x. 7. Training a model, example. Command is model.compile, optimizer equals atom. Loss equals sparse_categorical_cross entropy. Metrics sadface accuracy. Model.fit, train_images, train_labels, epochs equals 10. This code compiles and trains a simple neural network model using TensorFlow/Keras. 8. Saving and loading models. #save a model. Command is model.save, my_model.h5. #load a model. Command is loaded_model equals keras.models.load_model, my_model.h5. You can save and load trained models using these commands. These are some of the basic commands you can use in TensorFlow to create, manipulate, and train machine learning models. The exact commands you'll use depend on your specific machine learning tasks and models. Manipulating TensorFlow. Manipulating tensors in TensorFlow is a fundamental aspect of working with the framework. Tensors are multi-dimensional arrays, and you can perform various operations to reshape, slice, combine, and modify them. Here are some common tensor manipulation operations in TensorFlow. Reshaping tensors. Command is tf.reshape, reshapes a tensor into a new shape. Tensor equals tf.constant, 1, 2, 3, 4, 5, 6, reshaped_tensor equals tf.reshape, tensor, shape sadface 2, 3. Slicing tensors. You can use indexing to extract specific elements or slices of a tensor. Command is tensor equals tf.constant, 1, 2, 3, 4, 5, 6, slice_tensor equals tensor, 0, 1, #extracts the element at row 0, column 1. Concatenating tensors. Command is tf.concat, concatenates tensors along a specified axis. Tensor_a equals tf.constant, 1, 2, 3, tensor_b equals tf.constant, 4, 5, 6, concatenated_tensor equals tf.concat, tensor_a, tensor_b, axis equals 0, #concatenate along the first axis, rows. Splitting tensors. Command is tf.split, splits a tensor into multiple tensors along a specified axis. Tensor equals tf.constant, 1, 2, 3, 4, 5, 6, split_tensors equals tf.split, tensor, number_size_splits equals 3, axis equals 0, #split into 3 equal parts along the first axis. Transposing tensors. Command is tf.transpose, transposes the dimensions of a tensor. Tensor equals tf.constant, 1, 2, 3, 4, transposed underscore tensor equals tf.transpose, tensor, hashtag transpose rows and columns. Element-wise operations. You can perform element-wise operations like addition, subtraction, multiplication, and division on tensors. Command is tensor underscore a equals tf.constant, 1, 2, 3, tensor underscore b equals tf.constant, 4, 5, 6, result equals tf.add, tensor underscore a, tensor underscore b, hashtag element-wise addition. Reduction operations. Command is tf.reduce underscore sum, tf.reduce underscore mean, and other reduction functions compute statistics over tensors. Tensor equals tf.constant, 1, 2, 3, 4, 5, sum underscore tensor equals tf.reduce underscore sum, tensor, hashtag computes the sum of all elements mean underscore tensor equals tf.reduce underscore mean, tensor, hashtag computes the mean of all elements. Broadcasting. TensorFlow allows broadcasting, where smaller tensors are automatically expanded to match the shape of larger tensors in element-wise operations. Command is tensor underscore a equals tf.constant, 1, 2, 3, scalar equals 2 result equals tensor underscore a asterisk scalar hashtag broadcasting scalar to match tensor shape. 9. Masking and filtering. You can create masks or Boolean tensors to filter elements in a tensor. Command is tensor equals tf.constant, 1, 2, 3, 4, 5, mask equals tensor 2 filtered underscore tensor equals tf.boolean underscore mask, tensor, mask. These are some of the essential tensor manipulation operations in TensorFlow. Understanding and mastering these operations is crucial for working effectively with TensorFlow when building and manipulating neural networks and other machine learning models. Thanks for watching my video. I try to make more video for you. You can also check my related video in I button. If you like my video, please subscribe and share with your family and friends.